Hi everyone, today we'll be looking at the Pure Mathematics 1 October 2021 paper of the International A-Level. In question 1 we need to find this integral, so the first thing to do is write out the integral in a form that allows integration to happen without any mistakes. So the over root x will be written as x to the minus a half, and then the 3 over 2x to the power of 4 will be 3 over 2x to the minus 4 dx. We now increase the power by 1, dividing by the new power, and then 1 over 6 is x to the half over a half, minus 3 over 2, x to the minus 3 over minus 3, plus c, the constant of integration. We have simplifications here. The 12 with the 4 leaves me a 3, the 2 with the 6 leaves me a 3 in the denominator, the 3 with the 3. So to give each term in its simplest form, it has to be 3x to the power of 4 plus 1 over 3x to the half plus 1 over 2x to the minus 3 plus c. Do not forget the plus c, it's indefinite integration, so it needs to appear in your final answer. Question 2, we are being given the curve with equation 3x to the power of 5 plus 4x cubed minus x plus 5. We have 2 points P and Q lying on the curve, and we are told that the gradient of both of these points is 2. So I will start by finding an expression for dy dx. So dy dx is 15x to the power of 4 plus 12x squared minus 1. So I get the power down, deducting 1 from the power, and I know the gradient at P and Q is 2, so dy dx is 2, which means that 15x to the power of 4 plus 12x squared minus 3 is 0. I will divide throughout by 3 to get 5x to the power of 4 plus 4x squared minus 1 is 0. And this is actually a disguised quadratic in x squared. So I will let w be x squared. This certainly means that w has to be 0, and also means that w squared is x to the power of 4. So if I rewrite this quartic in terms of w, I see it is simply 5w squared plus 4w minus 1 is 0. This factorizes into 5w minus 1, w plus 1. So it either means that 5w minus 1 is 0, or w plus 1 is 0. If 5w minus 1 is 0, then 5w is 1 and w is 1 over 5. And if w plus 1 is 0, then w is negative 1, and I reject this since we said that w has to be greater than 0. Now w is x squared, so x squared is 1 over 5, which means that the x values at P and Q are plus minus the square root of 1 over 5. Question 3, the first part, independent of the second, appears with the Roman numerals. We need to solve 3 over x is greater than 4. We have to be careful here because x appears in the denominator. So I need to make sure that when I deal with these kind of inequalities, I'm always multiplying by non-negative quantities. So I will multiply both sides by x squared to secure that I'm not multiplying by something that could potentially be negative. This means that I get 3x greater than 4x squared. 0 is greater than 4x squared minus 3x. I will factor out the x to give me x brackets 4x minus 3. And I see that the critical values are at x is 0 and 4x minus 3 is 0. So 4x is 3, giving x is 3 over 4. It is a smiley parabola, there it is. I will put in the critical values of 0 and 3 over 4. It goes plus, minus, plus, and I want to be less than 0, so I want the negative part here. So we want all values of x such that x is between 0 and 3/4, and both of them are strict inequalities. Now in II, we have a schedule of the curve C here. We have the straight line L. L has a gradient of 3, so I will add this information here. The curve C has equation y is 2x squared minus 50. We are also told that C and L intersect on the negative axis. This here is a cut on the x-axis for the parabola, so I can find that point by setting y to be 0. So, II part here. Y is 2x squared minus 50. We've got a cut on the x-axis, so I will put y to be 0, which means that 2x squared minus 50 is 0. I will divide by 2 to get x squared minus 25 is 0. So x squared is 25, so x is plus minus 5. I will go back to my diagram to update it with this new information. So this point here is negative 5, and this point here is 5. So for the straight line L, I know that it passes through the point minus 5, 0 and has a gradient of 3. So I could actually come up with its equation. So this is what we know. Gradient of 3 and passing through negative 5, 0. So using y minus y1 is mx minus x1. Out getting y minus 0 is 3 brackets x minus minus 5. So this means that y is 3 times x plus 5. So y is 3x plus 15. So we have just derived the equation of the straight line. I will add this on the diagram as well. And we want to come up with inequalities that describe the region shown here. Well, it certainly has to be above the straight line, below the parabola. But if I just stick to these two inequalities, it means that I'm also including this part here, where I'm also above the line and below the parabola. Now, in order to restrict myself and just take up the region R here, I need to say that x has to be less than negative 5. I could use strict or relaxed inequalities, that's okay here. So this means that I have to be above the straight line, I have to be below the parabola, and I have to be to the left of the cut on the x-axis, so x has to be less than or equal to negative 5. Question 4, we've got a sketch of the graph of cos 2x, and we need to state the coordinates of q and the coordinates of k. Well, we know that the cos of 2x is a stretch along the horizontal scale factor of a half, so we divide all the x values by 2. We know that the original cosine wave is cutting at 90, and then we've got at 180 a minimum point, and then at 270 another cut on the x-axis. All of these will be divided by 2, which means I've got a 45 here. The point Q here is at 90. The minimum is not affected in the sense that it is still at negative 1. So we still have Q having a y value of negative 1. And then every 90 degrees, we will be having a cut on the x-axis. So this is 135 and this is 225, which pretty much reveals the coordinates of Q. And we've got that the coordinates of Q are 90 minus 1. We also have to find the value of R. Well, R is here, and the value of K, because the point R has coordinates K, 0. So it's obvious that K has to be 225. So that's the second part of A. So K is 225. Now, for B part, given that there are exactly 2 solutions to the equation cos 2x is P, find the range of possible values of P. So what I can do is start off by drawing a horizontal line and then just investigate how many cuts we have. It's obvious that below negative 1, it's going to be no solutions. At negative 1, it's 1 solution exactly. Then it's 2 distinct cuts up to the point where we hit the x-axis where we've got more cuts. Then it's going to be 3 cuts, 3 cuts, 3 cuts. And then there's another interesting case here where we have two cuts exactly because we hit upon the maxima here and here. Obviously, for values greater than this point over here, it's going to be no solutions again. So at this point, P is 1, and over here it has to be strictly between -1 and 0. So my answer for part B would be P is 1 or -1 less than P less than 0. Question 5, it's the line with equation 3y minus 2x is 30. Now we've got the second line, it passes through the point A, 24, 0, and is perpendicular to L1. And the two lines meet at point P, and we need to find the coordinates of P. I will actually start with L1. The equation is 3y minus 2x is 30. The idea is to put it in the form y cos mx plus c in order to derive its gradient. Dividing throughout by 3 gives me 2x over 3 plus 10, and therefore the gradient of L1 is 2 over 3. Now L2 is perpendicular to L1, so it means that the gradient is minus 3 over 2. We flip and we change the sign. And in addition, we know that it passes through the point A, 24, 0. So using y minus y1 is mx minus x1. We get that y minus 0 is minus 3 over 2 x minus 24. And I will expand this to get y is equal to minus 3 over 2 x plus 36. For the point of intersection, the point P, I'm essentially solving a system of simultaneous equations. So I'm setting the two lines to be equal. Minus 3 over 2x plus 36 is 2x over 3 plus 10. I will get rid of the fractions by using the LCM, which is 6. This needs to be multiplied by 3, this by 6, this by 2, and this by 6. Which leads to minus 9x plus 216 is 4x plus 60. I will collect the x's on the right, the numbers on the left. So 216 minus 60 is 4x plus 9x, leading to 156 is 13x, which means that the x is 12. We haven't finished, we need to find the value of y as well. So I can say y is 2 over 3 times 12 plus 10, substituting in 12, 1, which gives me 18, and therefore the coordinates of P are 12, 18. In B, given that L1 meets the x-axis at the point B, we need to find the area of triangle BPA, and I will actually draw exactly what I have gathered up to now just to get an idea of what the triangle looks like. So I will start by finding where the line L1 cuts the x-axis. So the line L1 had equation of 3y minus 2x is 30. Now we meet the x-axis, that means that the y is 0. So if I put y to be 0, I get that negative 2x is 30, and therefore x is negative 15. We've got a cut at B, which is minus 15, 0. I will now draw what I have gathered up to now. So this is the situation here. We've got the point B at minus 15, 0. We've got the point A at 24, 0, and the point P at 12, 18. It's obvious that the base is just 15 plus 24, which is 39. And the height is the y value of P, which is 18. And therefore, we can simply say that the area of triangle BPA is the base of 39 times the height of 18 over 2, which is equal to 351 squared units. In question 6, we start off with an equation f of x. It's 2 brackets x plus 1 x minus 3 squared, and we need to sketch the graph of C showing all the cuts or meets with the coordinate axis. So let's first investigate exactly what we're dealing with here. We've got f of x is 2 brackets x plus 1 brackets x minus 3 squared. So if we expand this, it's going to be a cubic with a positive coefficient for x cubed. So the shape will be something like this. We also can find the cut on the y-axis by setting x to be 0. So f of 0 will be 2 times 0 plus 1 times 0 minus 3 squared. So this is 18. So we've got a cut at 0, 18. For cuts on the x-axis, we've got f of x is 0, which means that 2 brackets x plus 1 brackets x minus 3 squared is 0. So either x plus 1 is 0, which gives me x is negative 1, or x minus 3 is 0, which gives me x is 3, but this is actually a double root. This means I've got enough information for me to sketch what's happening here. So this is the y-axis, this is the x-axis, and we know we've got a cut at negative 1 and then a double root at 3. So this is 3, this is negative 1, this is 18, and this is f of x. Remember, it's a sketch. We only need to show the basic features. Now in B, we need to write f of x in this form, so we're pretty much being asked to expand this. So we will start with the factorized form of f of x is 2 brackets x plus 1 x minus 3 squared, which gives me 2 brackets x plus 1 brackets x squared minus 6x plus 9. And I will further expand into x cubed minus 6x squared plus 9x plus x squared minus 6x plus 9. Collecting the like terms, it's 2x cubed minus 5x squared plus 3x plus 9, which is 2x cubed minus 10x squared plus 6x plus 18. So this is the expanded form we had to find. And then part C, hence find the equation of the tangent to C at the point where x is a third. So I will start by differentiating, and I will also find the y value when x is a third. So the first thing to do is find the value of y, so f of a third, which means I will substitute 2 times a third cubed minus 10 times a third squared plus 6 times a third plus 18, which is giving an answer of 512 over 27. Now f dash of x, the derivative, I get the power down, deduct 1 from the power, and I will evaluate this at x is a third. So f dash of a third will be 6 times a third squared minus 20 times a third plus 6, which gives me 0. Now the fact that the gradient is 0, it means that we are looking at a tangent which is a horizontal line. So tangent is a horizontal line, and therefore the gradient is 0. So it should be a line of the form y equals to a number, and it's of course the number 512 over 27, the y coordinate of the particular point. Of course, you could have done it the long way by considering y minus y1 is mx minus x1. I will replace y1 with 512 over 27, m is 0, and this is still an acceptable answer. We haven't been specified of a particular form to be giving our answer to. In question 7, we have this design for a sign at the bird sanctuary. We've got that OC and OA are 0.6 meters. We always add up the information on the diagram just to have all the information in one place. We've got BC and BA being 1.4 meters. And we are also told that the angle OCB is 2 radians and the angle OAB is also 2 radians here. Now in part A, we need to show that theta is 1.64 radians to 3 SF. And what I will actually do is I will draw the OB line and use cosine rule to find the length of OB. I could work in this triangle here and just say that OB squared is equal to 0.6 squared plus 1.4 squared minus 2 times 0.6 times 1.4 cosine of 2. Remember, your calculator has to be in a radian mode, and this is 3.0191, and I take the square root to give me a value of 1.73756 meters. I will add this on the diagram, so this is the 1.73756 meters. And I can work again now with the sine rule. The angle here is theta over 2. So with the sine rule, I could say that sine of 2 over 1.73756 dot 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 is equal to sine theta over 1.4. I'm using full accuracy, that's why I'm putting the 3 dots here. I don't want to be penalized for premature rounding errors. So this is theta over 2 actually, not theta. And therefore 1.4 sine 2 over 1.73756 dot 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 is sine of theta over 2. If I do shift sine, I get 0.822 is theta over 2, and therefore if I multiply by 2, I get 1.64439 dot 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 is theta, and therefore theta is 1.64 to 2 dPs as required. Part B, we need to find the perimeter of the sine. Well, the perimeter will be the length of the major arc plus the 1.4 and the 1.4. Now that we know theta, we can easily say that this here is 2 pi minus theta. And we know that the length of the arc is r times the angle. So for the perimeter, it's going to be the radius 0.6 times 2 pi minus 1.64 dot 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 the angle of the major sector plus 1.4 plus 1.4, and this is giving an answer of 5.6 meters. And then for part C, to find the area of the sine in squared meters, where it's simply the area of the major sector plus twice the area of this triangle. Now for the area of the sector, I'm using a half r squared theta, and for the area of the triangle, I'm using a half AB sine C. So the area is equal to a half r squared, so 0.6 squared 2 pi minus 1.64 dot 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 plus 2 times the area of the triangle, which is a half AB sine of the angle in between, sine of 2, and this turns out to be 1.6 squared meters. In question 8, we begin a sketch of C with this equation here. It's a quadratic, a SAT parabola, and we need to write 4 plus 12x minus 3x squared in the form a plus b brackets x plus c squared. So we are essentially being asked to complete the square. So 4 plus 12x minus 3x squared, we will factor out the negative 3, and it's going to be x squared minus 4x. And then I complete the square on 2x squared minus 4x. It's 4 minus 3 square brackets x minus 2 squared minus 2 squared. So this is 4 minus 3 square brackets x minus 2 squared minus 4. which upon further expansion will give me 4 minus 3 brackets x minus 2 squared plus 12. So this is 16 minus 3 brackets x minus 2 squared, and therefore the value of A is 16, the value of B is negative 3, and the value of C is negative 2. Alternatively, we could have equated coefficients, so we know the form of the answer. So we pretty much have 4 plus 12x minus 3x squared to be written in the form of A plus B brackets x plus c squared. I expand the right hand side into B brackets x squared plus 2cx plus c squared, which upon further expansion is giving me A plus bx squared plus 2bcx plus bc squared. I'm now equating the x squared term with the x squared term here, so negative 3 is equal to b. I will then equate the x term with, on the left, with the x term on the right, so 12 is 2bc, which means that 12 is 2 times negative 3 times c, which is 12 is negative 6c, and therefore minus 2 is c. And finally the constant 4 with a plus bc squared, so 4 equals a plus bc squared means that 4 is a plus negative 3 times negative 2 squared. 4 is a minus 12, so again we recover that a is 16. And then in II, hence or otherwise state the coordinates of M, we know that the minimum point, the maximum point here is attained when the bracket here is 0, and this will happen when x is 2, and when x is 2 this is 0, and therefore the y value is 16. So the coordinates of M will simply be 2, 16. So in all such cases, we need to make the squared bracket 0, and whatever is left is the value of y. The line L1 now passes through O and M as shown. A second line L2 touches C and is parallel to L1, and we need to find an equation for L2. So what's happening here is that we've got another line L2 which is parallel to L1 and just touches the curve, so it's tangential. So this is L2 here. The two lines are parallel, so they share the same gradient. We know for L1 that we pass through the origin and we also pass through the point 2, 16. So it's easy to see that the gradient of L1 will be rise of 16 over run of 2. So I will start by saying that for L1, we know that the gradient is 16 over 2, which is 8. It passes through the origin, so it's the line y is 8x. But I will also consider the derivative of the curve. We had y is 4 plus 12x minus 3x squared. So dy dx is 12 minus 6x. And we know that this second line L2 should also be having a gradient of 8. And therefore this means that 12 minus 6x is equal to 8. So 4 is 6x, where we get 2 over 3 is x. This is the x value. So at the point that the line touches the curve here, x is 2 over 3. So I will substitute to get y. So to get the value of y, I will simply say that y is 4 plus 12 times 2 over 3 minus 3 times 2 over 3 squared, and this is 32 over 3. We're trying to find the equation of this straight line. I'll be using y minus y1 is mx minus x1. So y minus 32 over 3 is 2 over 3 brackets, it's 8 brackets x minus 2 over 3. And since I haven't been specified any particular form in which I need to give my answer, I will actually leave it as it is. Question 9, we start off with f of x being root x, and it looks something like this. The point P93 lies on the curve, and we're being asked to sketch on diagram 1 f of 2x and f of x plus 3. And I will actually start by considering what each transformation is. So for A, f of 2x is a stretch along x scale factor of a half. So we multiply all the x's by a half. So this is the action that needs to be taken, multiply x by a half. It means that the point P93 will go to 4.5, 3, and for y is f of x plus 3. It's a vertical translation by 3 units, so it's translation, so translate 3 units up, which means add 3 to y, and therefore the point P93 will now go to 9, 6. So we need to still sketch this. So we need to go to diagram 1 here. The graph of f of 2x will be something like this. So this here is the new point P. It's 4.5, 3. And this is y is f of 2x. And the graph of f of x plus 3 is going to be something like this. This is the point P96. Actually, the y-intercept is now at 3, and this is y is f of x plus 3. So these were the sketching of the transformations. And then B, show that the x-coordinate of Q is the solution of this. Well, the point Q is the point at which the two curves meet. Well, we know that f of 2x must be the square root of 2x, and f of x plus 3 is the square root of x plus 3. So we equate these two. Root of 2x is root of x plus 3. So root 2 times root x is root x plus 3. I will collect the root x terms on the left. So I've got root 2 root x minus root x is 3. I will factor out the root x. So root 2 minus 1 is 3. Leading to root x is 3 over root 2 minus 1. I haven't really finished. I need to rationalize the denominator by multiplying by root 2 plus 1 over root 2 plus 1. Now it is clear that the numerator is simply 3 brackets root 2 plus 1. And the denominator, well, the root 2 times root 2 is 2. The middle terms get cancelled out because it's the difference of two squares. And then you've got minus 1. So it's 2 minus 1. Therefore, root x is 3 brackets root 2 plus 1 as required. So that was part B. And then in part C, hence find in its simplest form the coordinates of Q. Well, I have to find x and then proceed to find y. So we know that root x is 3 root 2 plus 1. So that means that x will be 3 squared root 2 plus 1 squared, which is 9 brackets 2 plus 2 root 2 plus 1. So it's 9 brackets 3 plus 2 root 2. Now for y, I will be using the root x plus 3. Well, root x is 3 brackets root 2 plus 1 from the final answer in part B, and adding the 3. So this is 3 brackets 3 root 2 plus 3 plus 3, which is 3 root 2 plus 6. And therefore, the point of intersection Q has coordinates 9 brackets 3 plus 2 root 2, comma 3 root 2 plus 6. In question 10, we have the curve f of x. We're being given an expression for f dash of x, the derivative of it, in terms of a is a constant. We are also told that the second derivative is 0 when x is 27. We are told that we pass through 1 negative 8, and for 3 marks we need to find the value of a. So I will start by considering f dash of x, which I've been told to be ax minus 12x to the 1 over 3. I will differentiate to get an expression for the second derivative. So f dash dash of x is a minus 12 times a third x to the minus 2 over 3. So this is a minus 4x to the minus 2 over 3. Now f dash dash of 27 is a minus 4 times 27 to the minus 2 over 3, which is a minus 4 over 9, and this is equal to 0 according to the second bullet point, and therefore a is 4 over 9. Now for part B, we need to find f of x. So I will start by integrating f dash of x. So it's the integral of 4 over 9x minus 12x to the 1 over 3 dx. We increase the power by 1, dividing by the new power. So it's going to be x squared over 2 minus 12x to the 4 over 3 over 4 over 3 plus c. Do not forget the constant of integration. We do have simplifications here. The 4 with the 2 leaves me with the 2. The 12 with the 4 leaves me with the 3. And this is giving me 2 over 9x squared minus 9x to the 4 over 3 plus c. We know that we pass through the point 1, negative 8, which means that f of 1 must be giving me negative 8. And therefore 2 over 9 times 1 squared minus 9 times 1 to the 4 over 3 plus c is negative 8. So on the left hand side it's minus 79 over 9 plus c is negative 8, which gives a value for c of 7 over 9, and therefore my final answer will be f of x is 2 over 9 x squared minus 9x to the 4 over 3 plus 7 over 9.